Welcome back to Designing AI-driven Personalized Learning Environment course, week 3.3 Overlay Model. Overlay model is one of the well-known or industry standard learner model. Everybody talks about it. Let's see what is overlay model. It's very basic learner model. I think we discussed this even in last week, I guess. So in the overlay model, the most common approach, it's been developed from 1970s. It's the idea that the expert's knowledge or the domain model or domain is the expert knowledge of the content. If I want to teach a content and the domain knowledge have a structure of subtopics, the connection between subtopics is properly connected. That knowledge is the expert knowledge, the world knowledge or the expert's view on that. How each learner is performing in that expert's knowledge, it's become the learner model. I think we discussed this in our last class. I think I'll go back a bit more here. It's kind of a checklist approach. For example, I think as we discussed last class, if I have multiple concepts, the experts thinks is that in order to complete this concept, a student should answer 20 questions here. In order to complete this concept, the student should answer. So there are sort of concepts or notes are connected, something like that. If a student answers all the 20 questions, the student 1 is able to have an expert knowledge in this. They move on to next topic. Some student have a struggle saying that he has only 6 questions out of 20. You have only 2 questions out of 20. You have like 3 questions out of 20. Something like that. You know what happens? This particular student model is less knowledge on all these 4 concepts, so we need to provide a more content and adaptation on that. That is the expert and domain each learner model. So why it's called overlay model? Expert knowledge is always on the sheet, it is on it. We are overlaying each learner performance on each node to find out whether the learner is learning or not. So it's called overlay model. So imagine this transparent sheets, which I don't know whether most of you remember. In olden days, before the projector, everything, we used to have lectures where they use the transparent OHT projectors. They keep it there. The sheet is projected on the board. So imagine there is a expert model on this. Okay. Now I want to project student 1 on this. Okay. This is a student 1. Student 1 is like another sheet. Student 1 performance is kind of this. He is able to do only set of few questions. Okay. Now I will go for another student. This student performance is say 6 out of 20. They're like 13 out of 20. 8 out of 20, something like that, So here each student's performance is overlaid on the expert model. That's the idea of the overlay model. Let's say it starts with a very basic domain model which contains every rule, concept, skills and everything. If a student does all the rules properly, all the concepts correctly, then we measure the student's performance and compare with them, and we say that a student is done with this particular domain, move on. So student have this knowledge of expert level. If a student have no knowledge on that, we would say that okay, the student has 60% of knowledge on concept 1, 30% knowledge of concept 2, based on number of actions they do, number of correct questions they do. So each student will have a different knowledge on the topic. That is why it's called a student model. Okay, so as the student correctly answers the question, we say check off the student has particularly answered all the question correctly, so we can move to the next topic. So how the student's performance is recorded in this particular model? For example, S1, S2, S3, S4, there are a lot of students. Okay, like 100 students considered. This is topic 1, topic 2, topic 3, topic 4, many topics. So here I put 0.8 percentage or 0.3 percentage, 0.6 percentage, some numbers I can started answering it. So the expert model is always one, everything is known, everything is complete. How much a student performed on those expert model on each topic is the expert this learner model would come in. So it's the same topic, each learner have a different level of thing. For example, this learner will be having same thing, but maybe this learner will have 5.8. It's also different, that's a different. Either you want to find this minuscule difference and provide a personalization separately, or you want to cluster them and make it consider a group. It's up to the pedagogic concept, but we want to capture the differences among learners on these concepts in the model. So the overlay model is simple. It's very transparent model, which is each expert's knowledge is a worldview. Each learner's performance on each sub-concepts is recorded as the table. That's called the overlay approach in the learner model. Using this data, I could overlay, go back and check them, which feedback to give, what kind of data I should give. I can do all of those detail here. Okay. I hope this is clear, the overlay model. If you want to look at again in more generated image using AI, the domain model rules, concepts, skills are here, and here the domain model is actually of expert created content with lot of concepts and nodes. In each node, you measure the learner's performance, concepts, and add it. And if it does correctly, the student checks off the answers. That's all. It's very simple. Then it moves on to the next particular node. So, but overlay model is binary or non-binary. For example, in a check mark the questions, are we simply considering a student knows the answer if it is 1, not knowing the answer is 0? So out of 60, out of 20 problems, we say it answered 12 problems correctly. But you assume kind of learner is, answer is 0 or 1. Instead of learner, can we go for the probabilistic overlay model? Well, the knowledge is not represented as, he knows the topic or not. Instead, it's a probability, 80% confident the student might know this addition. There's a probability of 0.85. So the overlay model can be binary, where the knowledge can be represented as 0 or 1. For example, student knows the addition or not. The student knows this concept 1 or not. If the student have particular threshold, the student understands the topic. Or we could have probabilistic overlay like what we saw in the previous slide. We can measure 0.6 or 0.8, something like that. If I have multiple questions, I can measure it. So probabilistic overlay model is kind of more preferred compared to the binary overlay model. That was the very beginning. So it says the system is 85% confident the student knows this addition. Although out of 15 questions, student might have answered 13 or 12 questions, something like that. So it's more of number of questions increase so that we can measure the probabilistics layer. Also, if you have more ins used, if time spent, we can also use that knowledge for the overlay model. So it seems overlay model is very perfect. For example, it breaks the topic into subtopics, and it actually gives you a lot of information about each subtopic, 10 questions or 5 questions. Then it's very easy. For example, it says students have ability of 0.8 in addition, students have ability of 0.7. Using that information, we can do a lot of personalization. But is it good? Does it have any limitations? Is it all about the learner modeling? I think we saw more things in learner modeling. But what is limitation of overlay model? Why it's not capturing more information? Can you think about it? Write down the 2 limitations and play the video again. The standard overlay model assumes that all student errors are caused by lack of knowledge. If they answered correct or wrong, we don't know whether student why they not able to answer is not considered. We consider only the response is correct or wrong. They might have incorrect knowledge, the misconceptions. They might be knowing something, or they might be missing some knowledge which to apply in the right place. They know how to add, but when to add they don't know. So it's what to say, it's basically the overlay model thinks that student answers right or wrong. It's not knowing what mistake they're doing, why they are missing it. It's an issue. So that's we saw that the the very famous problem of fraction addition. The student adds the denominator. So we know that don't know they have to add an equal denominator. So the solution is that we saw in the last rule based model, can we combine overlay model with the buggy library model? We saw the buggy library model where the student's performance is kind of tracked and the bugs also can be tracked. So here the thing is, two model will be there. One is overlay model where students knowledge on expert domain model is captured. Also students overlay on the buggy rules. There are a set of buggy rules for each concepts. How many misconceptions students have in each concept is also captured. By combining these two, we would say that student have an issue in the concept 2.1, but also the student have misconception in these particular misconceptions. So that would help the personalization to do better. So that's the idea of combining overlay model with the bug library. It's called perturbation model. That's the idea of to solve the problem of limitations of a overlay model. Thank you. I hope the overlay model is clear. The overlay model is a very classic model, and it actually talks about how well the student's performance is matching with the domain expert, that is the expert knowledge. That's all. And with the help of buggy library, we could able to understand where the student lacks, also what misconception they hold, how much is the knowledge in a particular topic, do you have any misconceptions, how to be captured. If you have this information, we could have a better pedagogical logic we could think of. Thank you.